Okay, so here is the first example. All fish live in the water. Whales are not fish. Thus, whales do not live in the water. Something sounds strange, huh? Because you do know that whales do live in the water. But here's one thing that I should tell you at the beginning. Don't try to make sense. Don't try uh, to ask yourself if a statement is true or not. Okay, so for instance, the fact that you know that whales do live in the water, okay, set that knowledge aside. Okay, because what you're looking at is just a pure structure of the sentences, the logic. Right, and so whether these things are true or not, whether they make sense or not, whether they are in English or not, should not be a concern to you. I mean, you do have to understand certain subset structures. Okay, but that's really all you need to know. All right, so let's draw a Venn diagram and try to understand if this statement is valid or not. All fish live in the water. Okay, notice here, all fish live in the water. You see two sets of things here. All fish, we have a fish circle, and that has to be the inner circle because the first statement is already saying it's a conditional. If X is a fish, then X lives in the water. All right, so live in water. So these are all things, maybe be very specific, all things that live in the water. Okay, this is the correct subset structure. This Venn diagram, or this diagram, tells you that all fish live in the water. That is exactly the set of two circles I drew, is exactly what the first statement says. Okay, I hope you get that, right? So this also says if something is a fish, then that something must live in the water. Okay, that's exactly what the first statement says. Now let's look at the second statement. Whales are not fish. So where are the whales? All this says is that whales do not belong to the inner circle. So that means whales could be here, whales could be here. The point is that this first statement and the second statement does not tell you whether the whales are here or here. In other words, you don't know if whales are inside of the outer circle or outside of the outer circle. The conclusion seems to say whales do not live in the water. The conclusion is that the whales must be out here, but we don't have the reason to believe, we don't have any reason to say, to assume that the whales are here, because all you are told is that the whales are not in the inner circle of fish, right? That's a second statement. So the answer here is that this is an invalid statement. Okay, why is it invalid? Because all you can say by the first two statements is that the whales are outside of the inner circle of fish, and we do not have a grounds to say that the whales are outside of the outer circle. All right, so anytime you are ambiguous, like in this case, are whales here or here, then the conclusion or the logic structure is invalid. All right, let's go to the next one. And by the way, you notice here that the conclusion is false, right? But that does not make this invalid. I want you to know that because you could have a true conclusion and you could have an invalid argument, but you could have a valid argument where the conclusion is not right. Okay, look at number 2. All US presidents have been men. That small or short sentence by itself allows you to draw two circles because you see the two sets of people, US presidents. This is a very small set of people, right? Only about 40 some people, depending on how you count, because one of those people is counted twice, Grover Cleveland. All right, and then the next one says men. So all US presidents have been men. Now this is a big group of people, right? And so this is the statement. This is the Venn diagram reflecting the first statement. All US presidents have been men. If X has been, or if X was or is a US president, then X must be a man. Okay, that's what the first statement says. Now the second statement says Abraham Lincoln was a man. Therefore, Lincoln was a president. Now you happen to know that he actually was a president. So the conclusion is true. But remember, that does not make the argument valid. That is a crucial point that you must understand in this section. All right, what does the second statement say? Abraham Lincoln was a man. So all you know is that Lincoln is inside of this outer circle. Maybe he is in here. We just don't know that, okay? Because the second statement, the only thing the second statement says is that Lincoln belongs to this outside circle, not necessarily in the inside circle. Maybe he is inside the inner circle, but it does not say that. So we have this ambiguity. We cannot conclude, therefore, that Lincoln must be a president. It happened to be a true statement, but this argument is invalid. Did you get that? Okay, it is a classic case of an invalid argument with a true conclusion. The conclusion happens to be true by luck, maybe. And again, you can sort of replace this with somebody else. Let's say all US presidents have been men. Okay, that's true. Michael Jackson was a man. Therefore, Michael Jackson was a president. No, it doesn't quite work that way, right? So maybe replacing this name with somebody else could give you the idea that this is invalid. So very important for you to remember these faulty arguments. Okay. All right, number 3. If it's Tuesday, the bank is open. Today, the bank is closed, and therefore, it is not Tuesday. Does it sound right? Well, we don't know. Okay, let's look at this. If it's Tuesday, so here is the inner circle. And by the way, notice here, every time I analyze all statement or if-then statement, I am using Venn diagram representing the subset relation, right? If it's Tuesday, the bank is open. So Tuesday happens to be a set, the smaller set, and the outer circle is technically days the bank is open. It's wordy, okay? You can just say open, and that's okay too. So Tuesday happens to be one of the days that the bank is open. The bank may be open in other days. Hopefully it is, if it's a regular bank, right? But Tuesday definitely is one of those days when the bank is open. That's what the first statement says. Now, today the bank is closed. So where is today? If the bank is closed today, it is not the day when the bank is open. So the today belongs here. The second statement clearly indicates that that today is one of those days that belongs to outside or the exterior of the outside circle. Okay, let me ask you this question. If you are outside of the outer circle, can this be inside of the inner circle? No, if you happen to be outside of the outer circle, there's no way you can be inside of the inner circle, right? It is very clear. Today must not be Tuesday, okay? So this is a valid conclusion. Guess what? This is a valid argument, okay? So because today, yeah, let me just go ahead and write today here. That today, oops. All right, so I'm going to use my pen and say today must be here. And clearly it is outside of the outer circle. So it is a valid argument. Okay. Now, if the first statement is true, if it's Tuesday, the banks are open, okay, and today the bank is closed. If these two statements are true, then because the argument is valid, that would force the conclusion to be true. Okay, and in that case, we say this is a sound argument. Okay, not only is it valid, that if the statements are true, then that would make it a sound argument, and that would force the conclusion to be correct. Get that? All right, number 4. Everyone in America watches the Super Bowl. Oh, so you say, oh no, but that's not true. Okay, forget what is real and what's not. Remember what I said? The reality or what is meant by each statement, or if each statement is true or not, that is not what you need to be concerned with when you are checking the validity of an argument. Okay, so let's just assume that this statement is true. We need to draw a picture. Everyone in America. So this is the set of people in America, okay, watches the Super Bowl. Okay, so that's the Venn diagram that goes with the first statement. Everyone in America watches Super Bowl. If you're in here, then you watch the Super Bowl. I don't live in America, so where are you? Therefore, I don't watch the Super Bowl. Okay, does it sound correct? Well, let's take a look. I don't live in America, so you are outside of the inner circle, right? And something is wrong with my PC. I will be right back. All right, sorry about that. I don't live in America tells me that I could be here or I could be here, okay? The fact that I am outside of the inner circle does not tell me whether I am inside of the outer circle of the ones who watch the Super Bowl, or am I inside of the outer circle or am I outside of the outer circle? There is a level of ambiguity, and therefore I cannot make this conclusion. Okay? Therefore, I do not watch the Super Bowl. This is saying, hey, look, I am outside of this inner circle, and therefore I must be outside of the outer circle. No, I can't say that. So this is invalid. Okay, so far I have invalid, invalid, valid, and invalid argument, right? So hopefully you are getting the hang of on this idea. Number 5, everybody in America watches Super Bowl. Oh, that's the same picture. Okay, so in America, Super Bowl watching people, same diagram as before. This time though, the second statement says, I live in America, so I am right here. Okay, I am right inside of the inner circle. Okay, now let me ask you this question. If you are inside of an inner circle, does it mean that you are inside of the outer circle? And the answer is absolutely yes, right? Because this is the inner circle. Every element on the inner circle, every element in the inner circle is all automatically inside of the outer circle. That's what the subset relation means. Okay, if you belong to the those who are in America, then you belong to the group of people who watch the Super Bowl. Now that is not a true statement, right? In reality, not everybody in America watches the Super Bowl. I know because I don't. All right. Well, so the conclusion is false. But this is still a valid argument. Okay, this is a situation where the argument, the structure itself is valid, but because the first premise or the first statement was false, the conclusion did not end up being true. Okay, so this is a valid argument, but it's not a sound argument because there was a false statement in the premises. Okay, but again, this is a valid argument. The structure itself is correct. If the first statement happened to be true, and if the second statement happens to be true, then the conclusion would have been correct. All right, so yeah, that is a lot of things maybe to digest. Let me give you a little summary of what we have talked about here. Okay, so looking back, example 1 was invalid. Why was it invalid? Because the fact that whales are outside of the inner circle does not mean that the whales must be outside of the outer circle, right? That's what makes this invalid. The second one is similar. This one says the Lincoln was a man. He is inside of the outer circle, but that does not mean that he is also inside of the inner circle. So that's invalid. Okay, the third happens to be valid because if you happen to be outside of the outer circle, there's no way you can be inside of the inner circle. And then the fourth one is invalid for the similar reason as which one was it? As the first example. Okay, just because you are outside of the inner circle does not mean that you must be outside of the outer circle. And that was exactly what the problem was with example 1. So 1 and 4 are both invalid for the same reason. And then number 5 is valid because if you are inside of the inner circle, then you are automatically inside of the outer circle. And this this last one, number 5, okay, it's the logical rule, and you can read more about this in section 1.4 of the book. But in the argument type we use here in example 5 has a fancy Latin phrase, and that is the words modus ponens, okay? And this is saying if P, then Q, okay? If that's true, if that is true, if P then Q, okay? And then if you can establish that P is true, let's put it this way. If P, then Q is the first premise, and then you have established that P is true, then therefore Q is true. That turns out to be a correct statement. Just read this. If P, then Q. Okay. P is true, therefore Q is true. That's like saying, if you live in California, you live in America. You live in California, therefore you live in America. Okay, that is a true statement, right? Basically, this is saying if you belong to the inner circle, then you must be inside of the outer circle as well. Now, example 3 was also valid, all right? And that argument type is called modus tollens, okay? Modus tollens or tollens, right? And this one says this, if P, then Q is true, okay? Now, Q is false. If Q is false, then P must be false. Think about this. If you live in America, I'm sorry, if you live in California, you live in US. Well, you don't live in the US, therefore you do not live in California. Okay, and that is negating the consequent. I mean, what this is really saying is the contrapositive. Okay, if the negation of Q is true, if Q is false, then P cannot be true. P is false, and that is a true or the valid statement by contrapositive. Now, 1 and 4 are fallacy of the inverse. Okay. What is this saying here? Remember what inverse is? If P, then Q, that's the original statement. The inverse is saying if not P, then not Q. P is false. Therefore, Q is false. Okay, this is not valid. Put it this way. If you live in California, then you live in America. I don't live in California. Therefore, I don't live in the United States. See, that's a fallacy. That's wrong, right? That's invalid. Because what you're doing is you're negating P, and then you are concluding that the negation of Q holds, and that's not true. Remember, that is called an inverse, and the inverse does not have or is not logically equivalent to the original statement. Example 2 is called the fallacy of converse. If P, then Q is the starting point. And then remember what converse is? The converse is to say that if Q, then P. Q is true. Therefore, P is true. So you can't argue this way. Again, if you live in America, if you live in California, you live in America. I live in America. Therefore, I live in California. No, it doesn't work that way. So just because Q is true does not mean that P is true. Unfortunately, many people say things like this in their conversation or in their messaging or in their lectures, but you can't reverse the order. Just because Q is true does not mean that P is true. So this is also a fallacy, and this fallacy type is called the fallacy of the converse, right? So these 4 things I stated here, it all starts with the same thing. If P, then Q, okay? If P is true, then Q is true. That is valid. If Q is false, then P is false. That's also valid by contrapositive. 1 and 4. So this third statement here is showing you the fallacy of the inverse. The inverse is not the same as the original conditional. The last one saying that the converse is not logically equivalent to the original conditional. All right, with that in mind, I think you are ready to answer these questions on quiz for section 1.4. And once you think you get the correct answers, try the online versions, pretty much the same questions. And if you get any of these wrong, then look up the answers in your Canvas shell and in the module for chapter 1, and correct your mistake or mistakes, and then challenge again. You have up to 3 attempts for these quizzes. Okay, I hope you get this, and you can now analyze the deductive arguments.